All right, I think I'm going to get started. I want to say hello and welcome everyone to this LebNet webinar on 5G. My name is Fram Akiki, and I'm honored to be your moderator here today. I'm the president of Joun Technologies. We're a company that's focused on management, technical, and educational services with current projects in the field of 5G, digital transformation, and smart connected devices. I've been in the industry for 35 years, including executive assignments with IBM, Qualcomm, and Siemens. So today's LebNet webinar, it's part of an ongoing series of webinars that LebNet has been running on several very interesting topics, ranging from the impact of COVID-19 to the outsourcing of technical projects to Lebanon. If you've missed any of the LebNet webinars, I strongly encourage you to go back and watch them. They are all available on YouTube, and this webinar will be as well after 24 hours. So a few housekeeping items. Everyone other than the panelists will be muted. So at any time, if you have questions, please send them via the Q&A box that's on the bottom of the Zoom menu. There's a Q&A box and there's a chat box. The Q&A box is for whatever questions that you might have. And we're going to select a few of them at the end to address in the last 15 minutes or so of the webinar. If you're having any other issues or logistical issues, please send a message in the chat box to George Aii. George is on, he's our LebNet CEO. He's monitoring both the Q&A box and the chat box on this webinar. So I'd like to introduce this very impressive panel members that we have today. Walid Ali-Ahmad, Vice President, Cellular SoC System and Architecture at Samsung Electronics. Majed Al Amine, Managing Director of Technology Strategy at Accenture. Ibrahim Gedeon, CTO at Telus. And Ali Khayrallah, Engineering Director at Ericsson Research. So let me set the stage. When I look at the evolution of cellular standards, for me, three major points kind of jump out. The first, a new standard tends to get deployed about every 8 to 10 years. Second, the deployment of the standard usually lasts around 20 years or more with upgrades along the way, which means we tend to have a lot of overlap in standards. And then third, and arguably probably the most important, each standard has tended to have a killer app which drove it. So, you know, anything from analog voice with 1G up to video streaming with 4G. And so if we focus on 5G and the underlying technology for a second, you hear a lot of discussions about the triangle of benefit to consumers and applications. You know, up to 10 gigabits per second throughput, 1 millisecond latency or the response of the network, and 1 million connected devices possible within a square kilometer. And of course, you know, for the network and backhaul ecosystem, which we have well represented on this webinar here today, the ability to deliver all of this in a much more efficient manner. So Majid, I'd like to start with you first. Maybe tell us a little bit about your role at Accenture and how do you see this 5G market impact?
Yeah, hello everyone. So my role at Accenture, I lead the next generation technologies for telcos at Accenture in North America. So we basically work with telcos around 5G like today and virtualization, cloudification of the networks, etc. I actually, before joining Accenture 5 years ago, I was at Huawei in China, which I know it's a topic of discussion for many people nowadays. But basically, I did like 3 or 4 years of R&D in China around the evolution of technology of 5G, but also on the virtualization, on the mobile edge computing and other topics. And originally, I started working as a radio engineer, actually, in the old days in Motorola. So I built networks in Middle East, Emirates, Qatar, Saudi, Egypt, other places, and so on. So my career started with what you showed as the 2G play. I never saw the 1G. I wasn't alive, but the 2G play forward, I think it's in the last 20 years, it's been a crazy market of changes, like with companies popping in and out, with like devices of Ericsson, Nokia, and all these players in the devices disappearing and new giants coming in, with equipment providers coming in and out. So the reason I'm saying this is relevance has been a very key important area. Relevance means you always have to be up to date and ahead. And I think this is why 5G today is the talk of the day, because people don't want to lose that relevance with a new technology and new generation. However, I think the impact on the market is a little bit of a difference between 4G and 5G. In my mind, it's not another extra G. On maybe the wireless interfaces of technology, it is an evolution or like an extra G. But what happened in the development of 5G is people decided that they don't want to carry the burden of the legacy and come at it as a completely new approach. So in my mind, 5G is not just a wireless technology. It's actually an evolution of the internet, or basically the next phase of the internet, where you basically have everything hosted and connected through this network rather than just having a fast network. So containing everything on that network and being able to look at, I think we'll discuss it down the line, but looking at service-based architectures, which is basically enables all developers in the world to come and develop on 5G rather than, in 4G, no one was asked to come and develop an application. On Android and iOS, you did, but not on the network itself. While in 5G, you'll be surprised how open and service-based it's going to be. And that's going to be the biggest impacts, where both industries and developers and on the consumer side and industry side are going to have to collaborate to push that generation into like becoming the new internet, from my mind.
Well, thank you, Majid. So one thing I want to tell the other panelists, I am not going to ask who remembers 1G or who doesn't remember 1G, so you can rest assured on that one, okay? Ali, tell us about your role at Ericsson, and how does the 5G feature rollout look like over the next 3 to 5 years?
Okay, first, thanks for having me. So I've been with Ericsson 25 years, all of it in a research role, anchored in research and working with various organizations within Ericsson along the way. I manage currently a research team in Santa Clara, and we're working on 5G and what's beyond 5G and other kind of forward-leaning questions like satellite and so on, as well as spectrum sharing. We also have interactions with academia and government agencies and so on. And we do some technology scanning for the CTO office of Ericsson. I personally spend some of my time preaching to the heathens in Silicon Valley about mobile technology, but that's kind of my personal cause here. So about 5G and deployment. So first, let me spoil the surprise a bit and start from the end. So we're in the midst of a very large deployment wave currently on a global scale. And I have a few notes here. In the US, we have 7 announced 5G contracts and we have 5 live networks. In Canada, we have 3 announced contracts, including Telus, I think, in June. And on a global scale, we have 95 commercial agreements, as they call them. 54 of them are public and 40 live networks. So it seems that even with the virus situation, this has not slowed down at all, as far as I can see from my vantage. And then let me sneak in a few basic things. Mobile networks for us in research, it's about spectrum. Spectrum is the scarce resource, and you can add whatever. Of course, antennas, you can transmit, you can receive, you can phase them, you can distribute them, you can do all kinds of magic with antennas. You can use power, but it's only useful to a point because it's we call it interference limited network. So if you just keep shouting up and up, nothing happens. And of course, then we design the interface using coding and modulation and all the goodies that I like. So 5G is an air interface, and we're in the middle of developing it, of course, and then we're of course, designing products to comply with the standards and deploy them and so on. So what makes 5G somewhat different from what came before is there's some key salient features in it. One is that multi-antenna systems are sort of baked in from the start. Another is it has this flexible air interface structure, which allows it to operate nicely at different frequencies. And the combination is golden in the sense that you can now move out of the traditional mobile frequencies, which works roughly below 3 gigahertz, and go up all the way to 52 and now beyond gigahertz. What's called millimeter wave, even though it's on the very low end of millimeter wave. But once you have more spectrum, you immediately have more bandwidth, you can have higher throughput, you can have bigger capacity and so on. So it really opens things up for you. In addition, 5G is also expanding beyond its kind of somewhat narrow, even though it is a huge business of serving smartphones, essentially, if we look at 4G. And so now we're looking at massive IoT, where you have many, many small devices which have kind of low capability, low requirements, but there's a lot of them. So they could be for sensors, actuators, for logistics, home automation, smart meters, you name it. And there's another extreme, which we call critical IoT, where you could have very tight requirements on latency, on reliability, and so on. That could be for traffic safety, industrial applications, healthcare, AR, VR, you name it. So those are kind of two extremes that are sort of we're trying to make the standard suitable for. In terms of the actual plumbing of the standard itself, in release 15, we developed the basic pieces needed so that you can deploy your first 5G network. In release 16, which ended in late 2019, there were more topics such as unlicensed spectrum operation, different spectrum bands, integrated backhaul and access, ultra reliability, low latency, and so on. And release 17, which started in 2020, but it's a little bit delayed because of virus logistics issues. It is currently working on further topics such as terminal power savings, network architecture evolution, non-public networks, moving the spectrum up to 71 gigahertz, I think, and a new mode of IoT called RedCap. Another kind of final point is that the satellite industry has come into the mobile standard world of 3GPP. So release 17 will also have the first 5G-based NTN, which stands for non-terrestrial networks, and it's primarily for satellites. So this will be the first standard for NTN based on 5G. So that kind of covers what's going on right now.
Wow, so a lot of stuff coming. Ibrahim, tell us about your role at Telus, and from an operator point of view, why are you excited about 5G? Tell me why 4G isn't good enough.
So basically, I'm responsible for effectively technology strategy at Telus, but we're DevOps. So I have security, for example, as part of our team, privacy, power and maintenance, mission critical environment. So it's a bit of everything, including wireless and of course the RAN and the core, and then Ericsson's one of our partners. But I want to go back to, so that's my role. I have a very modest small team, like 1,500 people or so. And we have probably the world's fastest 3GPP based 5G record with Huawei of almost 30 gigabits per second. But I resonated with a couple of words that Ali mentioned and Majid. It's not just another 5G. So what excites me is doing it right. Because for us, the 3G was the first time we disaggregated the baseband from the radio. And then we fiberized so Telus spent shitloads of money. Our peers thought we were stupid. But 3G was when we fiberized our base stations. 4G is when we put IP everywhere. So we have one IP network that does metro, TV, business, residential, wireless. And 5G, the reason I'm excited is honestly, it's where you're going to start enabling the end clients to run the network themselves. So we talk about the network as a service, IoT, whatever it is. It's not to get us out of the value chain. It's how do we enable them and the end value to the client. Or, you know, to be honest, we got the speeds, we got national coverage, we have the same stuff everybody else has. Get your device. If it has 5G, you'll get it. But Open Signal says our 4G, as you said, is faster than Korea's 5G. So if we're rushing to do 5G transformatively, we're rushing to do 5G, which actually will enable services that we don't have today, which is the key. Because if you're just pushing bits and bytes, we're just doing it for the sake of being good geeks and marketing kudos. So we'll tap ourselves on the shoulders, but when you spend a couple of $2 billion in capital every year, you're doing it to actually make a dent on the value chain, right? So there's new monies to be had, new opportunities, but not just by pure connectivity. The key is seamless end-to-end. How do you get the front end of an airline, hopefully they do, or a bank or an insurance company? So that's what's exciting us. And the other piece on the consumer side, which is very critical as an operator, and we're not as religious as Orange is. Like, I don't think AR, VR will make it or break it, but I think if you put gaming, if you put AR, VR together, it will appeal to a certain segment of consumers. Like, is it 50%? Is it 100%? I don't know. But if it's more than 10%, it's worth our while to invest in things like 5G to unlock that ARPU. So I know you said 5 minutes, but why be Lebanese when I can be Canadian? I'm done in 3.
Excellent. We like people that overachieve. So speaking of geeks, Walid, tell us about your role at Samsung. And, you know, everyone before you so far has been mentioning about this is more than speeds and feeds, right? There's all this other capability and network capability that's going to be there. What's that mean in terms of applications and devices besides smartphones that, you know, we might expect to see in 5G?
Sure. Thanks, Fram, for inviting me. And of course, George, too. So I had the RF systems architecture team at Samsung LSI. Samsung LSI is a division of Samsung Electronics. We're basically the business unit that develops the chipset for the Exynos platform, and that goes into Samsung phones and of course other phones in the future. And so I work on the layer between the antenna and the modem, and so the challenges that we see, of course, when you're dealing with application that now 5G is really based with, when I look at this, we always say that if you look at the 2G, 3G, 4G, the past 30 years, we spent really time on connecting people. We had one phone, and that was the device, correct? And we used that to connect people, and we've seen companies kind of benefiting from that, which is the social networking and the searching and the internet, and then the next 30 years is going to be really spent on how we connect people to their world, so to their devices other than just the phone. And I think from our side is that the challenges that we see is that 5G is bringing these new challenges as far as you're not building this hardware, that the chipset, into just a phone anymore. You're going into other devices, whether it's a headset for AR, VR, or whether it's an IoT device. So different challenges we're seeing there. And the key thing is that, the 5G, as Ali was saying, it's a very unique new wireless platform that presents. You're building a system across diverse services. So you're going from the mobile broadband to the massive Internet of Things to the mission critical services that we hear about, the drone delivering a package. And then you have the diverse spectrum that we also have to deal with right now. I mean, for the past 30 years, we've really been dealing with few gigahertz. Now we're talking about going all the way up to 50 gigahertz and so. And then also the diverse deployments. You're not only dealing with a base station to a cellular, We're also dealing, kind of connecting, like Ali said, NTN, which is terrestrial to the devices. So there's different challenges right now that we're seeing with 5G that are really kind of upping up the notch for us in development and the complexity of what we develop at the electronics level, at the chipset level. Okay, so we, as I said, what we're gonna be seeing right now is, if you look at the phone itself, just the smartphone itself, the challenges that where we used to deal with having the electronics sitting on a PCB, now we're having to deal with these antennas and these modules that are going to sit around the phone, and they're going to have to support this communication with the base station at these high frequencies, and having the ability to have a reliable communication and link with the base station is very challenging. Everyone talks about 5G, and it's such an exciting thing, but if you look at the number of 5G subscribers, still very small. The challenges of 5G and millimeter wave are big, okay, and are yet to be resolved going forward. Power consumption is big thing right now. One of the biggest challenges that we deal with right now is that when you put an antenna module around the edge of a phone, how it heats up when you're turning on these number of element is very important. So that's the challenges on the smartphone by itself. Now you go to new challenges that we deal with. I've worked at Facebook for a year and a half, putting 5G in a headset for AR, VR, that's the challenge by itself, because now these electronics that we used to have in a phone, now they have to exist in a different industrial design. Where would you put the antennas? Where would you put those? That's the challenge. These are the challenges we see.
Speaking about challenges and complexity, I wanna drill down a little bit on millimeter wave, because a bunch of you have brought that up. It's operating in a totally different spectrum. Can you talk just a little bit more about specific challenges? Walid, maybe first, and then anybody else. I want to talk about what is millimeter wave, the challenges between everything from antennas to how do you do carrier aggregation.
Sure, yeah. So when we were building 4G phones all the way up to LTE advanced, people were focused so much about we want to drive at the 1 gigabits per second in the phone. But in order to do that, we had to do a lot of aggregation across frequencies, across bands. And that actually made a lot of challenges in building the platform for something like this. So people said, what? The easiest way for me is to jump to a higher carrier frequency. And having a higher carrier frequency that gives me more bandwidth around that carrier, that's the easiest way. You have one carrier and all of that. But of course, the minute you jump to higher frequency, which is what people went up with the millimeter wave, is that the communication over the air between your base station and the phone is going to be seeing cement, is going to be seeing trees, and millimeter wave at those frequencies don't do well. You get your line of sight is going to be shrunk, and so that's the challenges as we go to these higher frequencies. Is first the communication space that we deal with. You have more challenges as far as attenuation of the signal. So that drives the request for a better link budget between the headset and the base station. But of course, as Ali said, you want more power, you can keep shouting more, but then phones and batteries cannot give you that. We have so much, we have so much limited space for electronics right now compared to the battery, allowed battery space. And so with all of that, we still have to have so many antennas and so many bands to cover with so little power. And so I think that the 5G, we're going to be seeing if the evolution of 5G is not just the application, it's really kind of the devices that we're going to use to make 5G happen, commercial, feasible. I would say similar to like the 4G that the past 10 years we've been When 5G will mature, it's not going to be now. It's going to be a few years from now when, you know, we're going to be, we're going to have CMOS, we're going to have devices that are going to be more efficient. Even architecture inside the phones are going to be more efficient. That's what we need when 5G will be a little bit more mature and I see more deployment in that regard.
Okay. Okay. Anybody want to add on to that?
Yeah, can I just add a comment? You can see with T-Mo and Sprint merging that they got this 2.5 gigahertz band, which used to belong to Sprint, and they got it from somebody else. And you know, in the old days, this used to be the kiss of death. You got that band, you were done. But now this is prime real estate, and I think the plan is to use low band, which I think T-Mo is already operating at 600 megahertz or 700 megahertz, and this mid band, or you know, low mid band, and millimeter wave. And then you put them all together. You don't treat them like three networks, but you treat them like one network, and you know, one big resource pool. And then the network will be tremendous. So I think all the operators, one way or the other, will have to do this kind of super carrier aggregation, not just, you know, to stitch together bands to get a wider one, but to also get coverage and capacity and in between and so on. So it's going to be a long slog.
So exactly, like, I mean, your carrier aggregation on steroids. So I don't want to deflate anybody on this, right? Like, you're just getting more bandwidth. You're actually, and every country is very different. I think, I don't know if it was, I apologize if it was Ali or Walid was mentioning it, but every country is appropriating spectrum differently. So Canada, we had to beg them to reverse mid-band and millimeter wave. And now the government announced that they're delaying because they're worried about our response to COVID, which has been fantastic, but I guess they have other reasons, so we'll take the blame. So mid-band is mid next year, and millimeter waves is 2021, 2022. And I think it puts carrier aggregation and HETNET on steroids, but in the end, it's just more bandwidth. I don't want to be rude. So it hasn't actually yet used, as we said earlier, all of us agreed, in some sort of format, that we have yet to use 5G as the transformational G, be it collapsed metro, like the single network, it's a mesh. Like, to be honest, we haven't done a lot of SDN yet in wireless. I find for those of us that have internet portfolio and wireless portfolios, there's a bit of a 3 to 4 years delay on things of those natures. So I'm agreeing with you, but I'm unexcited. Like, there's a question on the audience. Mark asked a question saying, what's the impact on kids? We're using the same frequencies on 5G we're using in 0G, like be it microwave, be it AWS. So, I mean, if the new transmission techniques are going to kill the kids, as God forgive me, but I doubt. It's the same. The spectrum is the same. We're using different attenuation techniques. I don't know what you guys think, but I got it from my doctor. So my GP phoned me up and says, Ibrahim, I have to talk to you. I said, okay, great. He says, well, what's the risk of towers, 5G towers on my health? Are you going to kill people? I said, okay, well, I mean, like, what am I running at it? Like, we're running at 2.8. We have 2.3. Sorry, gigahertz. We tend to geek ourselves to death. So it's what we use today for 4G. 3.5 in the UK, as you remember, with fixed wireless access, there was a couple that started with networks. I think PCCW out of Hong Kong did that. With Huawei Gear, I think, Majid, you were there at that time. It's like, what the hell? Like, everybody's healthy. So I think it's a bit of fake news for the not that I'm trying to emulate President Trump, but it's a lot of fake news and bullshit. No science involved.
I think one thing Walid mentioned around the challenge of millimeter wave, of like not being able to have the good line of sight. It actually, I mean, there's fairness in the laws of physics, because basically millimeter wave makes antennas smaller, and which means you have to put lots of antennas everywhere, which means the power will be way lower than passing through a macro tower and getting hit by that thing. So you're getting to a level where basically your devices that you were carrying with you, even your laptop with Wi-Fi, is shooting spectrum at you more than those smaller antennas that are going to operate on millimeter waves.
Yeah, I think you bring up two great points, right? First of all, where we're operating with respect to the spectrum in 5G is very similar to where we are in 4G. It's very far down in the non-ionizing part of the frequency spectrum, the overall spectrum. And the second item is the power levels are, very, very much lower. As 5G starts to come up, and this one is for the whole panel, what happens to 3G, right? So we saw lots of overlap in standards, right, as these things are deployed. 1G is pretty much gone now. There's, I think, still some pockets of 2G in the world, but does 3G go away? And does this become a 4G, 5G? Anybody want to?
For Ibrahim to answer, because we all got money for it. He paid for it. That's the difference.
We don't advertise too much, but what we have in 3G is for roaming inbound roamers only. So,
Okay.
so.
All right. So then, Ibrahim,
we never did 2G.
I'm going to come back right at you with something else. So Ali was mentioning release 16 unlicensed capability, right, for 5G gets put in there. So my question to you is unlicensed 5G private network kinds of things versus Wi-Fi 6. What's your view there, in particular, let's say for an industrial IoT application?
I have to be honest. It's only when we're if we don't make money on it, then it depends what we pay for it, right? To enable Wi-Fi 6 and the wide area network, for the lack of a better word, versus, and I don't really care. So I give you the question, I answer you the question a bit differently. I was at Apple like a couple of years ago when they were charging $100 more for the SIM-based iPad, if you guys remember. It was $100 US. Which really doesn't cost them much because the Qualcomm chipsets at that time, if I'm mistaken, were in the $20 range. So that's one of the highest margin. Like I wish I was Apple, right? Because you're paying less than $20 integrated and charging $100 more. And then they were complaining that it's not selling. So to be honest with you, to my colleagues and to everybody else on this, I think what COVID has taught us and where we're leading to 5G, I don't think the actual end consumer gives a shit. Like where they're coming from is, am I connected? Can I do my Zoom call? Can I do my Google Meet? And then where does the coverage go? So if I remember, I'll date myself. You were all dating yourself. I'm probably one of the older guys here, if not the oldest. In the old days, you did coverage, and then you went 4 years into capacity. And the most important thing was the highway. Do you remember that? That was the least important thing because you're sitting in friggin' Starbucks or Second Cup if you're Canadians or Tim Hortons. And that's all you care about. So the whole dynamics has shifted from. So I think as far as I'm concerned, from a purist point of view, it doesn't really matter to me if I can get ubiquity, if I can get free spectrum. Like the reason we like LAA and Telus is because I'm stealing free spectrum. So why would I, if I can run 5G on it, like why would I double invest? If I can use and I'm not religious at all, whatever protocol you use. As long as the customer is serviced in an optimal way.
So Ibrahim, you brought up the Apple connected device, right? And you're right. A lot of people who did connected devices were charging $100, $150. I was at Qualcomm at the time. I think Walid may have been as well. The counter to that, just to give you a little counterpoint, was a lot of people said, I don't mind paying $100 to get that capability. What I'm really upset about is paying an extra $15 or $20 a month to get the service to connect it. But
so I have to be honest, we didn't cover one angle.
Yeah.
The reason people prefer mobility versus Wi-Fi is for the security piece.
Yes.
For the lack
Agreed.
of collision. Like what I tell people, say, oh, Ibrahim, the Wi-Fi sucks at Starbucks. Well, if we're watching a football game, or in our case, a hockey game, and there's another 100 people having coffee and watching the hockey game, the Wi-Fi will be shit because the backhaul's the same. They don't guarantee the channel. And this is some of the things, thank you. I feel justified. But I think it's one of the angles that all of us alluded to, but the whole security aspect of it, the guarantees. is what you get. And if you, for all of us who remember the old days of standards, I think NIKE was the Wi-Fi extension that would guarantee semblance of mobility, but it's too friggin' painful. Too much work to emulate what you've got. By the time you run the cost structures, you're in the same cost structure we have now. So, which is the beauty of Wi-Fi.
Yeah, you know, to your security point, I was talking with a IT director, and they were mentioning employees in particular. They were going to Asia and connecting to quote free Wi-Fi, and about somewhere between 3 to 4% were coming back with viruses on their system that were requiring complete re-imaging, et cetera. It was a big issue. So that is a great point about the security of the cellular infrastructure. So Majid, I want to go back over to you. What role does 5G play, do you think, with some of the other technologies and buzzwords that we hear, you know, AI, AR, VR, in this whole bigger realm of digital transformation?
Yeah, if I would describe technologists today, I think the best thing to say is we shouldn't be astrologists. We shouldn't predict things. We should be more psychologists. We should pave the way for people to express their ideas. This is where technology needs to be and technologists should work on. So to answer your question, I mean, let me give you an example since we're mostly Lebanese. In Lebanon, when the wireless network came in and 2G was there, everyone was expecting that the use case would be, you know, I call my family, they call me, etc. Ended up being, I do a missed call if I arrive, 2 missed calls if I'm late, you know, stuff like that. So actually, if we knew the use cases, we would have put more signaling use cases more than like circuit switching use cases. So in a way, ultimately, the use case that the consumer or the end user needs and wants is going to prevail. Our job is to put it out there in a very convenient way and make them collaborate on it. So going back to AR, VR, I believe gaming is a quick win in a consumer perspective of trying to monetize 5G, especially with, like I was telling, how 5G is basically a new model in the core network where it says service-based architecture, which means you can push your compute capabilities in the network to the edge as much as possible, which enables lots where today your laptops or your devices do not have enough GPU to do that. While if you can do GPU on the edge of the cloud, then it becomes a more impactful thing. So it is a logical use case for AR and VR and gaming to happen away from the device and more in the network itself. That's why 5G is a play there. However, there's many things we would never expect, and this is where we need to open the environment, which is great that 3GPP and others created the 5G core with API-driven HTTP type of protocols where anyone can develop a function in the network, believe it or not, versus like we all, if we practiced in the past 20 years, 30 years, it was a very closed idea of like building any network element. Today, any industry, health industry has a different idea. They can create a virtual function and come to Ibrahim and say, host it for me on your edge if it's a latency thing, or in your core or whatever it is, and get the security perspective of it and everything in between. So in my mind, there's lots of use cases that we might imagine, and people here, participants, they should start thinking about it, because we are all developers in our DNA, and we can start developing. I'll give them one idea I want to develop, and if anyone in the participants would like to play with me, it's the idea of having better battery improvement in the life of the battery on the devices by hosting many processing on the edge of the network. So making your device more of a display and making most of your computing happening at the edge. The telco can help you, you pay them a little bit more, but you get double your power battery or something. So that's a completely different aspect from all the, technology-driven futuristic AI VR. It's a real use case where I don't want my battery to drain suddenly and my wife getting upset about where am I. Like, it's a simple use case.
In the industry studies, I saw them at Qualcomm, Siemens, and I'm sure everyone here on this panel knows, it's one of the #1 consumer feedback items on cellular devices, right? Which is battery life. In a lot of cases, it's also what causes consumers to upgrade their device. right? So that is a great point. So I know 5G is not, fully here yet, but that will not prevent us from looking even further into the future beyond 5G. And what might we be thinking about in terms of 6G? And for that, I guess I'm going to turn to you, Ali. Tell us, what do you think?
Yeah, so I understand that it freaks people out that we're talking about 6G at this time, but I've seen it before. I mean, both in in 4G and 5G. You have to start quite early and look at technology trends and understand them and see what they're for.
How early? How early do you got to start?
Not yesterday, last year, whatever it is. Because I mean, it takes a long time to integrate them into a complicated system. It's not just that you're looking at one thing and say, "Oh, this is going to solve everything," right? So based on my experience, I mean, you do have to start early. Of course, not your whole company, the size of Ericsson, has to be working on 6G, but slowly but surely you can see the beginnings of it. I mean, just to give you an example, I think in 2014, I organized a workshop on so-called 5G with Qualcomm in beautiful Asilomar, which we can't go to right now, on the coast. And people thought we were out of our mind, but I mean, sure enough, a year later or 2 years later, we were kind of in pre-standardization already. So you do need to spend the effort and the thinking into figuring out what you can do next. And I think you had mentioned like what could be in 6G. So I just have a few topics. Of course, they will change and they will come back and they will go and so on. But here's some. I mean, there's terahertz spectrum, which is getting deflated, so it starts at around 100 gigahertz in this case. So this could be the next kind of big band to look at. There's the radio front ends, and Walid can talk much more than I do about that. The radio front end is a big issue there. There's an activity already started by DARPA to build a test bed. So this is very interesting to us, and of course, different companies are looking into it. Another is the network topology. I mean, the super successful cellular network topology with backhaul and access, which has served us extremely well. But we haven't really touched it much in the past, 10, 20 years, whatever it is. So there may be time or opportunities to look at other topologies, multi-hop, and I mean, there's something called integrated access and backhaul, which is kind of along the way, and relays and whatnot. So this could be a big topic in 6G. Security, which of course we already have security in mobile networks, but if you widen the scope to include things like reliability and availability and so on, this could be, we tend to call it trustworthiness or trusted networks. This could be a huge topic for 6G or even at the end of 5G, maybe. We mentioned satellite and NTN. There's more and more thinking that, this could be the time for that again, and maybe integrating the two networks into one big humongous network with different nodes. People talk about zero energy, zero cost devices. You can think of it as like the extreme version of massive IoT, super simple devices, and many other things. And again, they will, some of them will drop out, some of them will come back, but eventually it will solidify into a new system, I hope.
Cool. Anybody else want to offer up?
Fram, I know you like jokes, so a few years ago, I was the chair of the RFIC conference. We had at the time the CTO of NTT Docomo, who was a plenary speaker, and he said, we asked him in one of the question in the audience, what do you think of 5G? And he made a joke. He said, in Japan, we look at numbers and we've seen that the past history of communication, typically the odd numbers don't do well. So 1G and 3G did not do well. So 2G was great, 4G was great. So you can expect what about 5G, So I think 6G is gonna be very good. That's I can tell you, based on Japanese wisdom. I think we're gonna learn a lot from 5G. When you look at how when we went from 3G to 4G or from 2G to 3G, we had CDMA, correct? I mean, we had CDMA, and people said, you know, I'm gonna put W in front of that CDMA, and they made it WCDMA, and soon discovered that it's not gonna cut it, you know, to get to mobile broadband. So they scrapped everything. Even Qualcomm dropped it and jumped into, correct, you know, jumped on LTE and 4G. So, and I think the same thing right now in 5G, we're still expanding from 4G. You know, we did scalable OFDM. We're doing a little bit different things. You know, we're expanding the spectrum, but who knows? People might discover that, we need to improve more, and maybe 6G will be more successful than 5G. For us, of course, the challenges as we talk about 6G, you know, from a hardware point of view, people are talking about 100 gigahertz and 200 gigahertz. So you know, even more challenges for us. But again, that's, as we say, 5G NR, no retirement, correct? So we're gonna be happy engineers going forward as we go to 6G. But I think we're gonna see, you know, stuff where it's gonna be driving more bandwidth, like holographic communication. This is something that at Samsung we talk about a lot. You know, we're gonna be talking about extended reality instead of augmented reality. And I see these things as more driving the required bandwidth and the kind of some of the latency requirement. And so, you know, this is kind of how I see it, you know. So we need to be watching how 5G is gonna evolve and the challenges and how these challenges are gonna project into defining 6G.
Mm-hmm. Yeah, and you talk about driving. I'm starting to see some of the Q&As come in. And we did get one question on self-driving and autonomous vehicles. And anybody want to comment on 5G experience there? I think Majid, you may have just answered.
I was trying to type some answers.
Yeah,
I think there is a quick jump to conclusions of self-driving cars and 5G in a sense of like the car would be like a remote controlled type of thing where it's wirelessly connected to the network and the network controlling the car. Actually, manufacturers today are thinking completely the other way. It's a super brain inside the car that is being invested on with hundreds of CPUs that will be going into the car to minimize any decision outside the car. However, of course, with time, they will start, you know, finding that going away from just connecting the car for the entertainment purposes, they will need connectivity to avoid forecasted accidents in front of you, et cetera, et cetera. But the initial phase, cars will be getting smarter and smarter, and the 5G network needs some time to get more reliability, to improve its latency, and ultimately have a cloud computing processing capability and with a mobility perspective, like you're handing over from one cloud to the other. That's still way ahead. So to keep it inside. Yeah, go ahead, Per. Sorry.
So, Majid, I'm disagreeing with you, but I find it was the sexiest thing that in 2014 when 5G came around was the autonomous vehicle and the self-driving. But let's be very honest with each other. Each auto manufacturer thought it was a lead. So they never really worked with each other until after 6 years or 5 years, they all failed. They said, maybe we should collaborate. And working with 3 out of the 4 German manufacturers ourselves with Vodafone, they're actually doing it alone. They're not thinking of working with the network. Like they're saying, oh, well, how much bandwidth can I get? And how can you activate the SIM? And I think being so my background, I'm more similar to Ali Walid. I actually built chipsets at Bell Northern Research before I went to Nortel and eventually got fired and then joined Telus. But they're not thinking at all about what the network is going to do. So to me, the coolest thing with all the compute, they never think of how can they be a Mac edge on the frigging car. So if you want to fast forward and intercept the technology, and we're getting a lot of questions we should probably answer about 5G business and revenue. I think this is the biggest hope that we will never realize because they're not sure what their competitive edge. So by the time you get an Audi guy and a BMW guy or Buick or GM guy talking in the same room, they agree that 5G is cool. but they would never share anything beyond that. And I think this is the issue operators have, and thus it translates to the Samsungs, the Ericssons, all the vendors, right? So yeah. It's not going to go anywhere. This is my view. This is my issue. Our biggest stumbling block as an industry is they view it as competitive. We view the way we can roll out our network site acquisition and spectrum holdings as competitive, which the others have, which is very different.
So yeah, you're right. We do have a question here. It says, appreciate the technical discussion, but can we shift to the business of 5G? How can my business derive benefits from 5G? How do I leverage it? What's in it for me as a business?
I can take the first swag at it. I think initially the first thing that we need to think about is how much businesses benefited from the internet. Like imagine the growth of everything from e-commerce to communication to gaming to everything on the internet. And think of 5G as another door to open more capabilities in the internet. So in the internet, you had connectivity almost instantaneously, but it's not. You didn't have latency and tactility. You didn't have massive connectivity at the same time. I mean, think of like a concert where you have 5 million cars parking at the same time in a city or in a place. That number of connections going at the same moment, those are new ideas that will come to your capability palette. And this is where your businesses start to look at, okay, so I had the connectivity door, now I have the latency and tactility door, I have the massive connectivity door. Let me think how I can, as a retailer or as a cinematic or whatever it is, how can I use this? And this is where people and the users have to come with creative ideas.
I think we'll probably see even new businesses and business models emerge out of this, right? So it's I think there's going to be that piece. Ibrahim, did you want to?
Sorry, I got excited, but I think one of the first valid reasons, and I apologize, I think Majid, you mentioned it earlier. I think what the business of 5G that's a bit different for us is going to be, if enterprises want to leverage this, they have to rewrite their applications, or they have to look at their digital journey. And instead of a bank having an app or an insurance company or a government or the city's garbage collection people, if you want to keep the same app and run it on 5G, it's easier. Upgrade your iOS. But I think if you want to leverage 5G, you have to write it with some of the new parameters. So I think the new business opportunity for technologists is the investments in those areas to leverage them. And the other one is looking at their digital supply chain to see how they can intercept their journey with where 5G is going. That's my humble opinion for the business, or else honestly, it's just another G. Like, why would you want a Mac? May I give you a small example on the airport? So Edmonton Airport, I live in Edmonton, which is kind of a village compared to most cities. It's 1 million people. It gets to you -40 in the winter, so Celsius for all those guys. So not even penguins will live there. It's that cold, but I love it. I want to give you the example that they build a car with 8 4K cameras, so they get 2 gigs worth of bandwidth to just see if there's deer, all these animals, something on the ground. So you'll have to send somebody outside at -40, but the wind could be -50, -60 to make sure the planes can land. This is at the airport, right? Very real use case. Today, a human being goes out in those temperatures. And then they realize, so we put a base station there because the president of the airport is a friend of Telus and they're a big customer. But the traffic was coming, going all the way to a traditional core, which is in another city, and coming back. So they were paying, it was 8 gigs of traffic. They were paying for 8 gigs going back so they can process on their own AI. So look at the delay. It's normal. Base station, you guys, goes to the MME, to all the gateways, goes to another city, comes back to them. So their AI engine said there's nothing. So even if there's no other traffic on the network, they've paid for 8 gigs back and forth. I have to charge them. They are using it. I mean, I know some people think the internet should be free, but you are using friggin' resources, right? That was an ideal local EPC and low latency use case. So there's real money. They look at it, they're paying a shift of 3 people on the car, then if one is sick. So there's 4 employees to drive that stupid buggy at weird temperatures. So they're $500,000. How much would they pay? So that's the business case. So this is real money. We're displacing real money. And I'm using it as an example because we actually, like, we can talk about it, we press released it. Sorry to, I just get excited because it's not AR, VR. Somebody asked the question, I get it. It's not my kid playing friggin' Pikachu shit, whatever it is, at my old age, or Minecraft. It's somebody who actually has money. You're displacing real dollars.
Okay, folks, the big elephant in the room, this is a question. The big elephant in the room is Huawei and the buzz around security. The question is, can we decipher this technically and say what we can to control security aspects as opposed to the political dialogue?
Do you want the politics or the security stuff?
Well, Ibrahim, why don't you start with the security stuff?
I'm uber passionate because in all the claims, it's never been an NSA guy. It's never been a CSE guy. It's always been CIA, CSIS, MI6, our prime minister, the US president. I'm a geek. Like, I did a few years of my life doing cryptography, right? With Diffie and Paul van Erschot. So nobody from that ilk said there's an issue. It's the politicians. So if we have a problem with China, which we may, and I don't want to talk about that piece, screw it. Just don't blame the geeks for putting shitty shit out there. There's some good R&D happening, and I get it just insults me. So if we have a trade problem, by all means, insert us. And I have to applaud, and not because I am flattering some folks, but I have to applaud Ericsson's formal stand, Ali, has been, let's treat everybody equal. So if we think this, somebody asked a question and I answered it on the, I think 5G is going to screw us if we treat it like 4G from a security point of view. And we should put the rigors and the demarks for all vendors equally if we care about our infrastructure. So I have Huawei, I have Ericsson, I have Nokia, and I have Samsung, by the way, FYI. So it's kind of a mosaic of all the vendors around the world. But I'm tired of this bullshit. If there's a problem between the West and China, I love it. Let's ban everything. Let's throw our iPhones and burn them.
Ali, do you want to comment? He brought up Ericsson.
Yeah, it's kind of hard to answer this question outside of the politics. I mean, you could, of course, have, we have standards and you can follow them. And, I think also, I mean, national operators have obligations to their own countries in terms of legal intercept and so on, which is not fashionable to talk about, but, they have to do what their countries tell them. I think with the current political situation, geopolitical situation, it has forced companies like Ericsson into modifying its supply chain and all kinds of things. But we think of ourselves as a global vendor. So for us, I mean, having fragmentation and these guys go on one side, others go on another side, that is not a happy talk for us, but we have to adapt to whatever is happening.
Yeah, so, we have another sort of related question, which is, will the market for 5G backhaul services be the same as 4G? And I'm going to throw another topic on top of that, which is O-RAN, right? And what impact do you think O-RAN might have? And maybe Ali, you want to start there?
Yeah, so I mean, O-RAN, for those who are not into the acronym business, it is outside of the 3GP standardization, and it's mostly talking about interfaces between pieces of the network and from the network to outside the network. And it's driven mostly by operators. And of course, Ericsson has never met a standards body it doesn't like. So we're in it and we're participating and we're developing and so on. We were not kind of one of the promoters of it, but it certainly makes sense. Now, that aspect is kind of very technical and people shouldn't care too much about it. But there's another aspect, which is about the so-called disaggregation of the network. So you would be able, in principle, sort of mix and match little pieces from different vendors. And that has not happened. I mean, you mostly see, even I don't know about Telus, but say Verizon has equipment from Ericsson and Nokia, they put them in different areas of the country. So it's really complete networks in a way from one vendor. So whether that happens is a very different question. This disaggregation business is way beyond just the interface.
Great. So we've come to the top of the hour, and I want to thank each and every one of you. This has been, I think, a great panel. I know if given the opportunity, we could go for hours and hours and hours more, but sorry, maybe we'll keep that to some future webinars, 5G Part 2, or a preview of